In this video, I will solve a JEE Main PYQ from the topic thermal physics. First, let me give theoretical background that is required to solve this question. Let us take a substance and let it be a solid, and let some amount of heat be supplied to it. Now, what will be the change when heat is supplied to your body? One of the changes, its temperature will go up. So, as I supply more heat, the temperature rise will be more. But will this go on forever? At a certain stage, the temperature will reach the melting temperature of this solid. Once it reaches the melting temperature, if further heat is supplied, the solid will start melting. So then we form a mixture of solid and liquid. So obviously we need a container to keep this thing. So if more heat is supplied to this one, then the amount of solid will reduce and the amount of liquid will increase until it becomes fully liquid. So started solid, supply to heat to it, its temperature will rise until it becomes a melting temperature. After it starts melting, and if heat is supplied, it will get fully melted. And at this point, the body has become fully liquid. But the temperature will be the same temperature, melting temperature. Because at this melting process, whatever heat is supplied has gone in changing the phase from solid to liquid, but not in increasing the temperature. So the amount of heat added is proportional to the temperature rise and also proportional to the mass. And the constant proportionality is physics of the substance. And when phase change is going on, the amount of heat added is proportional to the amount of mass, and the constant proportionality is latent heat of fusion. So for a solid, when heat is added, the amount of heat added is proportional to the temperature rise and also the amount of mass, and the constant proportionality is the specific heat of the substance. And when phase change is happening, here melting, solid to liquid, there is no temperature rise. So the amount of heat is proportional to the mass and is given by this formula. So these are the two formulas you have to remember. And one more thing is, when it's melting, it's a mixture of solid and liquid, and the temperature of the mixture will be the melting temperature. It won't be different. Because at this stage, if more heat is added, instead of changing the temperature, more solid will get melted and form liquid. So the phase change happens at a constant temperature. So with this understanding, we can solve the question. So this is the question. You can read it. Heat energy of 184 kilojoules is given to ice of mass 600 grams at minus 12 degrees Celsius. Specific heat of ice is 2222.3 joule per kg per Celsius degree, and latent heat of ice is 336 kilojoule per kg. 5 statements are given. Statement A, final temperature of the system will be 0 degrees Celsius. Statement B, final temperature of the system will be greater than 0. Statement C, the final system will have a mixture of ice and water in the ratio 5:1. Statement D, final system will have a mixture of ice and water in the ratio 1:5. Statement E, the final system will have water only. Choose the correct answer from the following options given below. Option 1 A and D only, option 2 B and D only, option 3 A and E only, option 4 A and C only. We have to find out which are the statements that are true. You can pause and run this question. So to start with, we have ice. At minus 12 degrees Celsius, and the mass of this ice is 600 grams. So heat is supplied to it, and the amount of heat supplied is 184 kilojoules. So as heat is supplied, the temperature of this ice will go up, say from minus 12 to minus 10, minus 8, so not with 0, and it will go beyond that if sufficient heat energy is available. So let us find out what is the amount of heat required for different steps. First step is to convert minus 12 degrees Celsius ice to 0 degrees Celsius ice. So the amount of heat required for this thing is mass and specific heat of ice into the temperature rise, delta T. So here the mass is given as 600 grams. In SI unit, it is 0.6 kg. Specific heat of ice is given in the question in SI units. And the temperature rise is 12. From minus 12 to 0, so temperature rises 12. So this calculation, if you do, it comes out to be 15.84. So once it becomes 0 degree ice, more heat is added, means it will start melting. So let us find the amount of heat required to melt the ice. So we call it Q2, that is mass of the ice into latent heat of fusion, solid to liquid. Mass of ice is 0.6 into latent heat of fusion is 336 kilojoules per kg. So 336 K. So this calculation if you do, it is greater than 184. So this is greater than 184 kilojoules. So melting of all the ice is not possible. So only some part of the ice will get melted, the remaining will remain as ice, solid ice. So to find that amount, you have to find the heat that's available for melting. So we call that Q melt, heat available for melting. That is the total heat supplied, 184 K, minus the heat used for raising the temperature to 0. So this much kilojoules, which will go in melting up part of the 600 grams. So let me call that mass melted into latent heat of fusion of ice, which is given as 336 K. So from this I get the mass of the ice melted. So this value is known. So if you do the calculation, we get as 0.5 kg. So these are simple numerical calculations you should be able to do. So this will come out to be 0.5 kg. So 500 grams of ice is melted to water and remaining. So the final state will be 500 grams has melted. So it will be 500 grams of water that's liquid plus unmelted ice, which is 100 grams. And the temperature of the mixture of solid and liquid is a melting temperature, which is 0 degrees Celsius. So final temperature is 0 and the mixture is 100 grams of ice and 500 grams of water. So statement A, we say the final temperature of the system will be 0, it's true, and B is false. Final mixture is ice and water in the ratio, ice is less, water is more. So the mass ratio is 1:5. So option D is true. So A and D are the correct statements. So correct answer is option 1. So that is the correct answer. So this is what I explained here. So to convert minus 20 degrees to 0 degrees, the amount of heat required is mass into specific to ice into increase in temperature. Increase in temperature is 0 minus 20 is 12. And this is given in the question. And mass of ice is 600 grams. In SI is 0.6 kg. So this I approximate as 2.2. And I've taken out K factor of 1000. So you do this calculation, you will come out with 15.84 kilojoules. And to convert 0 degree ice to 0 degree water, that's melting of the full ice. The amount of heat required is mass into latent of fusion, which is greater than 184, the supplied energy. Okay, so melting of all the ice is not possible. Only a part of ice will get melted. So you have to find how much of ice is getting melted. So heat available for melting the ice is the total energy supplied 184 kilojoules minus the heat used in the first step. The first step is to convert to 0 degree ice. So that is 178.16. That's equal to mass melted into the latent of fusion. This is given in the question. So from this we get the mass of the melted ice as 0.5 kg, which is 500 grams. So remaining 100 grams will be ice. So the mass ratio of ice to water is 1:5, and the final temperature of the mixture will be 0 degrees Celsius. So correct statements are D and A, and correct option is option 1. Let me explain an analogous situation. Suppose we have 2 points A and B, and the third point say C here, and let the distance between A and B be say 30 kilometers, and the distance between B and C is say 60 kilometers. So I'm moving in a vehicle, say a car, okay, and the fuel consumption of the car is, or the mileage of the car is, say 20 kilometers per liter, and the amount of fuel available is say 3 liters. So to find how far the car will move. So when the car moves from here to here, the amount of fuel used will be 30, so it will be 1.5 liters. So at this stage, the amount of fuel available will be 1.5, 3 minus 1.5. So with this 1.5, we'll go another distance of 30. So this is the final state. At a distance of 60 kilometers. Okay, so this question is similar to that. Initially, if you have ice at minus 12, to convert it to 0 degree ice, some amount of heat is required. I don't remember the value. And after that, it's getting melted. It forms a mixture of ice and obviously the amount of ice will be less than this one, plus water. So depending on the remaining heat available, this mixture, the fraction will be decided. So here it turns out to be, this ice, remaining ice will be 100 grams and this water will be 500 grams and the original mass is 600 grams.